Have you ever stopped to wonder how your phone knows exactly where you are? Or how a pilot can fly across a massive ocean and land in the right spot? Well, it's all thanks to this amazing invisible grid that we've wrapped around the Earth, a kind of universal address for every single point on the planet. So let's dive in and figure out how it all works.
We're going to start with a really common problem, something you've definitely faced yourself that actually has a pretty simple solution.
Okay, so picture this. You've just hopped off a train in a city you've never been to before. You're looking around, everything's new, and you've got to get somewhere specific. Your destination is the bank. So how do you get there? The answer seems totally obvious, right? But believe it or not, that simple answer is the first step in solving a much, much bigger puzzle. You'd use a map, of course. For literally centuries, maps have been our go-to tool for getting around. They're like a treasure guide, showing us where everything is and how to connect the dots. But here's the thing about local maps. They have a huge limitation. What happens when you try to map not just a city, but the entire planet? Yeah, that's where we hit a pretty fundamental problem. And it's a massive challenge. I mean, think about it. You're trying to take a sphere, a ball, and press it flat onto a piece of paper. It's just not possible to do it perfectly. A great way to visualize it is to imagine trying to flatten an orange peel. You can't do it without it ripping and stretching and looking all weird, right? Well, that's exactly what happens when we make a flat map of the Earth. So what's the solution? Well, you have to use a model that's actually shaped like the Earth itself, a globe. A globe is a true, miniature version of our planet, and it gets rid of all those annoying distortions. Okay, great. So the globe solves the distortion problem, but it kind of creates a whole new one. How in the world do you give a precise address for one tiny little spot on this big, giant sphere? The answer is actually incredibly clever, and the best way to understand it is to think about a game you already know how to play. Take a look at a chessboard. Any square on this board can be identified instantly and with zero confusion using a simple coordinate system, a letter and a number. For example, this pawn right here, it's on D4. Simple, precise, unique. And that brilliantly simple idea is the solution for our globe. We can just imagine wrapping the entire Earth in a grid, just like the one on a chessboard. This grid gives us the coordinate system we need. The horizontal lines on this grid, the ones that run east to west, are called parallels of latitude. They're all parallel to the main one in the middle, the equator, which we call 0 degrees. So latitude just tells us how far north or south you are from the equator. And then you have the vertical lines, the ones that run up and down, from the North Pole to the South Pole. We call those meridians of longitude. They measure how far east or west you are from an official starting line, the prime meridian. So here is the crucial point. When you put those two coordinates together, latitude and longitude, you can pinpoint any location on the entire planet. For instance, the city of Delhi has its own unique address, roughly 29 degrees north latitude and 77 degrees east longitude. It's a one-of-a-kind address for anywhere on Earth. But this grid system had a really cool side effect. It didn't just solve the problem of where we are, it also gave us a way to standardize what time it is all across the globe. The math behind it is actually pretty straightforward. The Earth is a 360-degree sphere, right? And it does one full spin every 24 hours. So if you just divide 360 by 24, you get 15. This means the Earth spins about 15 degrees of longitude every single hour. And that simple calculation is the foundation of all our global time zones. Each 15-degree chunk of longitude you cross means about a 1-hour shift in the local time. Pretty neat, right? Now, a system like this needs a starting point. Everyone has to agree on where 0 is. So back in 1884, an international conference decided that the 0-degree line of longitude, the prime meridian, would officially pass through the Royal Observatory in Greenwich, London. But what's really fascinating is that this idea of a prime meridian wasn't new, not at all. Centuries before that conference, ancient Indian astronomers had their own. It was called the Madhya Rekha, which literally just translates to the middle line. This ancient meridian ran through the city of Ujjain, and Ujjain wasn't just some random place. It was a major hub for mathematics and astronomy, and it just so happened to sit right on the Tropic of Cancer. It was the perfect 0 point. For centuries, this line was the fundamental reference for all Indian astronomical calculations and timekeeping. So, we've got these imaginary lines invented a long time ago wrapping around our planet. But why do they matter so much to us today in our day-to-day lives?
Because this invisible grid is basically the operating system for the entire modern world. It's what your phone's GPS uses to give you directions. It's how airplanes navigate those long flights. It's the reason global stock markets open and close in an orderly way. It even synchronizes everything from the internet to international phone calls.
When you really think about it, it's this incredibly elegant system of order that we've imposed on what is otherwise a chaotic world. It's a true testament to our ability to solve the most fundamental problems of place and time. So, we've uncovered this one powerful, invisible system that organizes our entire world. And it really makes you wonder, doesn't it? What other unseen structures, what other invisible grids are out there shaping your life every single day?